function. So this would be like y equals a number, right? If it's just a number, if there's no variable x, you just go to where that number is and you draw a horizontal line, right? So this would be the equation of y equals 3, right? Because our horizontal line is at 3. But the rule overall is y equals, like we said, a number or a constant without a variable. So we'll put y equals c as the rule, c for constant. Okay, in a picture like this, remember our line is continuing infinitely to the left and to the right. So my domain would be what? All real numbers. Good. Okay. What about our range?
3.
Just 3, right? So remember, if we're using our brackets, we just put brackets around the 3. The 3 is included. Okay? But remember, we also talked a little bit about before the break how you can write it different ways. This could also be written as like y equals 3. If you do set notation, same idea, but with the fancy brackets, right? Okay. All right. So then for that second picture, what is the equation for that second one there? Right, yeah. This is our y equals mx plus b, and in this particular picture, m is just 1, right? So just x. And our b is 0, right? So I don't have to put a plus 0 on the end. So this would just be the equation y equals x, right? Okay, again, remembering that our graph is continuous, right? Okay, so what would you guys say the domain for this function is? All real numbers. What about the range? Also all real numbers, right? Because it is going to continue up and down forever as well as left and right. Perfect. Okay, so this is what we call the linear parent function, right? It's just a diagonal line here. Okay? Then we have our quadratic function. What would be the equation for this one in particular? Y equals x squared. Very good. Doesn't have any changes made to it, right? Doesn't have a shift left, right, up, down, so it's just x squared since it's the parent function. Again, we're remembering that our graph is continuous here, right? Okay. What would we say the domain of this function is? All reals, right? Because it is going to go left and right. Okay, range, it goes up forever, right? So we would say that the range for this one is
Infinity. Positive infinity.
just infinity. So we have to say where it's to and from, right? So where did you say it starts?
0.
At 0. So from 0 to infinity, right? And 0 is a solid point, right? It's not an open point. It's a continuous line there. So if we're using our bracket, we'd say 0 to infinity, we use a parenthesis for. Okay? Or we could also write this as y is greater than or equal to 0. And if you were using set notation, same as that one, but with the fancy brackets, right? Okay. All right. Okay? Let's look at this next row here. So this next one is what we call a cubic function. So any idea what the equation of a cubic function is?
X cubed.
Right. So our rule here, or our equation, is just y equals x cubed. Perfect. Okay, what would you guys say that the domain of this function is? All real numbers. Good. And what about the range? Also all real numbers. Very good. Okay. All right. The next one is what we call the square root parent function. So any ideas on what the equation for this one is?
Y equals square root of x.
Right. Perfect. All right. Now, in this case, remember, we can't take the square root of a negative number, right? So our graph does not continue past this point, right? It stops there. Okay, it does continue this direction because we are increasing x values there. Those would all be x that would be positive, right? It just can't go any further to the left than 0. So it looks something like this with a endpoint here, an arrow over here. So what would you guys say the domain of this function is?
X is greater than 0. Greater than or equal to 0.
Or, what were you going to say?
Bracket 0 to infinity.
Both of those are correct. So 0 to infinity, and he was saying to use a bracket, or x is greater than or equal to 0. Both of those are correct answers. Okay, what about the range?
Is it 0 to
Same thing. All right, or y is greater than or equal to 0. Nice. Okay. This is the reciprocal function, also called a rational function. So we were graphing some of these right before the break as well. Do you guys remember where the x was when it had to give us something like this?
X.
Where the x in the equation is? So remember, right here we have what's called a what? An asymptote, right? And we said that means that's where x does not exist, right? So where can x not exist for a particular function? 0. Where am I not allowed to have 0? In the denominator of a fraction, right? So this would be the equation y equals 1 over x. Perfect. Okay. All right, now for my domain of this function, what would you guys say it would be?
All real numbers.
All real numbers except where?
0.
Right. So remember, we would say it has to go from negative infinity, right? Because it's going this direction. And it goes all the way to 0, right? And then we said it stops at 0. So the 0 is not included. So I'm going to put a parenthesis. If you would like, you can put a union there. And then it starts up again, right? Starts up again right on the other side of that asymptote, and it goes off to positive infinity, right? Okay? What would we say the range is? Same thing, right? Because here, I'm going to have an asymptote running this way, right? It never touches the x-axis. So it starts from down here, right? Comes all the way up, gets really close to 0. So it also goes from negative infinity to 0. Union picks right back up again right here. And it's going to go up forever. So from 0 to infinity. Nice. Okay. So there are some key characteristics. Oh, we got one more. Sorry. On the next page, we have our absolute value function. So anybody know what the equation for this one is? Yep, inside the absolute values. Very good. So y equals the absolute value of x. So this one has a lot of the same characteristics of your quadratic parent function, right? But instead of having that curve to it, it's those straight lines. Very similar, though. Okay, what would we say the domain is here? All reals. And what about our range? Right, and the 0 is included in this case, right? So we're going to put a bracket on that 0. Or you could also write it as y is greater than or equal to 0. Perfect. Okay. All right. So Now let's talk about transformations. So we already have done transformations this year, but we were only doing it for sine, cosine, right, our trig functions. So now we're going to look at what this would do to any function. So these are functions that you've actually transformed before, the ones we just talked about. They give us a little reminder here that anytime you have a vertical translation, that's when you're moving things either up or down, right? Vertical is up and down. You would find this in your equation as plus or minus something at the end of the equation. So if your equation was y equals x squared, you would have like plus or minus d at the end of the equation if it was shifted up or down some. Okay. It also says that if you were transforming a point, so like if you knew the coordinate point 0, 0, right, is on x squared, right? And let's say that we were to shift up 2 units. Then it says I would just add 2 to that function's coordinate point, okay? Or if I move to -2, I'd subtract 2 from the y value of the coordinate point. So this only affects the y value in your coordinate points. So this isn't going to make any changes to any of your x's, okay? Then we have our horizontal translations. So horizontal, as we know, is moving things left and right. So moving things left and right, this is found inside of a parenthesis. Right? So this part out here, this plus or minus d, outside of a parenthesis, left and right goes inside of the parenthesis. And remember, it's opposite of what you would think, right? This says minus inside of there, which normally we would think, oh, minus, negatives, those are to the left, but actually it moves it to the right. And here, this says plus c, which normally we would think means to go to the right, but it actually means to go to the left. So remember, when it's inside the parentheses, it's opposite of what we think it would be. And if I'm moving left or right, this is only going to affect the x value of your coordinate point. So if I told you to move 3 units to the right or to the left, you would actually do what you're thinking you're supposed to be doing. So here it said minus in here, but since that's moving to the right, on the actual coordinate point, it's not in parentheses anymore, right? This is going to come out. And you see what c actually is, so you add that amount. If you're moving right, you subtract that amount if you're moving left to your coordinate point. Okay? All right, then we have our reflections. So remember we said what would reflect our graph is if we put a negative in front of it, right? It flips everything over. So if I'm flipping over the x-axis, then I'm going to put a negative in front of the whole function or in front of the y. Remember, f of x is the same thing as y, right? Those can be used interchangeably. So they're saying all you would need to do to reflect over your x-axis would be to put a negative in front of your y or in front of the whole function. And if I'm reflecting over the x-axis, that means if I had a point up here, it would end up down here now. Okay, so this is reflecting over the x-axis. All that does is change the sign of our y. Now, if I reflect over the y-axis, it says you would want to be changing the sign of your x value, okay? Because here, on a coordinate plane, what this would look like is if I had a point here and I reflect over the y, it would just move it over here, right? So it says all you would do in this scenario is make the x value negative of your coordinate points. Okay? We also talked about stretch and compression. So you have a vertical dilation, or a vertical stretch is what we also would call it, as long as the a value is greater than 1. And it says a is going to be found at the very front of our function, right? So if a is greater than 1, so something like 2 or 7 or 10, right, then we consider it a stretch. because we're multiplying by that number, right? Multiplying something by 2 or 7 or 10 makes it bigger, okay? Now, if your A value is between 0 and 1, can somebody give me an example of a number that falls between 0 and 1? 0.5. If I multiply something by 0.5, is it going to get bigger or smaller? Smaller. So that's why we call it a compression, if that's the case. But also is still found out here in front of your function. That's where that A value would be. Okay? But this is multiplying all of your y values by something. So this would only change the y value in our coordinate point. So if you guys remember when we were doing our transformations for sine and cosine, we said the A value changes your y, but what we called the B value changed your x, right? And that's what we're going to talk about here next. Horizontal dilations are found in here beside the x, right? So not in front of the whole function, but in there with the x. And it's going to be the opposite of what we think, because remember, instead of multiplying by that number, we're actually dividing by that number, right? So if I were to divide something by something bigger than 1, like if I divide something by 2 or 7 or 10, it gets smaller, right? So if I divide something by that number, it actually is a compression. But if the number is between 0 and 1, like 0.5, right, that means I'm dividing by 0.5, which is the same as a half, right? Okay, well, if I divide a fraction, then really I'm multiplying by its reciprocal, right? Keep, change, flip. And what's the reciprocal of 1/2? 2. So really, if I'm multiplying something by 2, it gets bigger, right? So in this case, something between 0 and 1 actually makes it a stretch, right? And they tell us the rule here is that's what you're dividing your x value by. Okay, so here you're multiplying your y by a. Here you're dividing your x by b. Okay? All right, so now that we've kind of refreshed ourselves on those rules, let's flip it over onto the next page. And it says that what we're going to do is identify the parent function and then describe its transformations. Okay, so for part A, looking at all of those rules from our front page, as well as absolute value, which was on the second page, which one of our equations would x minus 1 quantity squared be? The quadratic function. Good. Okay, so this is the quadratic function, all right, which is just that parent function of y equals x squared, right? So this was what gave it away, right, that square. Okay? And then they want us to identify any changes that have been made from the parent function. Well, if this is the parent function, the only difference is this one has a parenthesis with minus a number inside of it, right? Okay, well, that chart that we just were looking at that tells us what kind of change that would be says if it's inside the parentheses and it's plus or minus a number like that, how is it going to move your graph? To the left and to the right. In this particular case, it says minus 1, so that means it's going to move to the right. Good. So here, when we're describing the change, we would say that it moved right 1. All right, so that's all they want you to do on this section. So I want you guys to try doing B, C, and D, and then we're going to share our answers here in just a minute. So I'll give you a moment to answer B, C, and D. So for part B, which parent function did you guys say this was? Cubic, good. Okay, so this is the cubic function, which is the equation y equals x cubed. So what'd you guys say the change was for this one? Right. Very good. All right, for part C, which parent function is this one? Absolute, good. All right. All right, so this one's the absolute parent function, which is y equals the absolute value of x. So what changes did you guys say were made here? Okay. Very good. So two changes. Reflect over the x-axis was the first, and then he also said that this shifted left 4 units. Very good. Okay, what about D? Which one is this one? Quadratic again. Okay, so quadratic would be y equals x squared. So what changes do we have? Up 7, okay. What else? Very good. A vertical stretch of 3, right? We know it's a vertical stretch because it was at the front, right? If it was inside with the x, then that'd be a different story, but it was in front of the x. So we know it's a vertical. Very good. Okay, next it says, given the parent function and a description of the transformation, write the equation of the transformed equation. So a number of the transformed function, letter A says the quadratic function. So we know that that parent function is y equals x squared, right? And it says it's going to be vertically stretched by a factor of 2, translated 7 units up. So I would write that as y equals, what would I put first? 2. And then what would I put? X squared plus 7. Right? And no need for any parentheses because we didn't shift anything left and right. Okay. All right, I want you guys to do B, C, D, and then we're going to share our answers out. Yeah.
Just rewind. For this one, for C.
Yep.
What did I put? Parentheses? 2000? Keep it like this.
You don't have to put an extra set. If it's absolute value, then the absolute value bar is kind of like this way. So you don't have to have an extra set. If you put it, it's not wrong, but you don't have to have it.
So I can just keep it as is?
Yeah.
Rational is a square root.
What is it?
Square root one, rational.
This one right here, we said that reciprocal is also called rational. Rational numbers is anything that can be written as a fraction, so that's where it gets its name. Okay, so for part B, said it was the cubic function, so we know that that is y equals x cubed. It says it's reflected over the x-axis and translated 9 units down. So what did our equation end up looking like for this one? Okay, very good. Awesome. All right, then we had our absolute value, which is y equals absolute value of x. It says it's translated 3 units up and 8 units right. So what did this equation look like? Okay, so x minus, I think it was translated 8 in this one, right? So 8, and then you said the plus 3 goes outside of the absolute value. Good. Okay, awesome. All right, and then this last one is our rational function. Remember, we said that on the front page, that one that was called the reciprocal could also be called a rational, is what I wrote underneath there. Your rational numbers are numbers that are fractions, right? So that's where it gets its name from, because it's written as that fraction. And it said this one was translated up 1 unit. So what did this equation look like? Right. Is the plus 1 in the denominator? No, just over here. Okay. All right, awesome. Okay, we've got one more section to look at here at the bottom. It says that we want to graph these, all right, transformations using our parent function. Okay, and then it says we will determine the domain and range of this new function. Yeah. So here, this one is which parent function on part A? Quadratic. Okay, so we know looks like this, right? So that's what this thing should look like. It's just going to have some changes made to it. Okay, so instead of starting at 0, 0, we know that our graph tells us we're going to shift down 2, and to the right 3. Okay, so I'm going to go down 2 and right 3, and that's going to be like my new 0, 0. Okay, so for our coordinate points, I'm going to just make a list of a couple over here. So originally, we know we had the point 0, 0. If you look back on the front page, on either side of 0, 0, we had a point at -1, 1 and +1, 1, right? So we got -1, 1 and +1, 1. Okay, this 2 right here, is that a vertical or horizontal? When the 2 is out in front like this. Vertical, right? Okay, so if you look at your little chart that was on your notes, it says when you have a vertical dilation, that only changes the x or the y? The y. So I'm just supposed to multiply my y values by that number, right? Okay, so we already said for our new points, instead of being at 0, 0, we put our next point at 3, -2, right? Okay, now I've got to change these values, right? Okay, well, I also, to get from 0 to 3, what did we do? Added, okay? All right, so then -1 plus 3 would be 2, right? Okay, so then this becomes a 2. How did I get from 0 to -2? Subtracted 2, right? Remember right over here on the table, we said that this means you subtract from your y value, right? Okay. All right, so then normally that would put it at -1, right? But then we said this 2 tells us we're supposed to multiply our y values by 2, right? So times 2, -1 times 2 would be -2. Okay, so we're going to have a point at, oh, nope, that's not right. Did I move my points to the right spots? -2, 2. Okay, that's my bad. Okay, so we're stretching, so it's going up. So here we were at -1, 1. Instead of you making all the changes so that you don't have to write so much work over here, let's think of it this way. Normally I would be going over 1 and up 1 and plotting a point there, right? But instead of just going up 1, this stretch tells me I should go up 2. So that way you don't have to fill in the table. Make it less work for you. So that'd put a point here, right? And then same thing over here to mirror it, right? Okay, and then that is enough for you to draw a little sketch to be able to tell me the domain and range, because that's all they asked for, right? Okay, so for your domain, what would you guys say the domain of this graph is? All reals, very good. Okay, all right, and then for our range, yes, starts at -2 and goes up forever, right? So from -2 to infinity, or y is greater than or equal to -2, whichever way you want to write it. Okay? All right. Okay, for part B, okay, this would be our square root function, right? We know that that looks like this is what the picture looked like. Normally starting at 0, 0, okay? But instead of starting at 0, 0, what do these transformations tell us to do? Move right 5 and up 3. Perfect. So same graph, because we're not stretching anything, right? Just instead of starting at 0, 0, it starts here. So then it goes off like this, right? Okay. All right, so what would you guys say that the domain of this function is? Very good. So 5 to infinity, or you can write it as x is greater than or equal to 5. Very good. All right, what would you guys say the range is? Very good. 3, right? Started at 3 and went off to infinity. Or y is greater than or equal to 3. Perfect. Okay? All right, for part C. Normally, our absolute value function looks like this, right? And that point is at 0, 0. Okay, but instead of starting at 0, 0, we're told to move to the left or right? Left 4 and down 1, right? Okay. This one does say in front we have a negative, right? So instead of plotting a point to the left and right 1 and going up, I need to reflect those. I'm going to plot points going down, right? So instead of putting them there, we would want to put one here and here. And again, that would be enough for us to give a little sketch. And now we can state the domain and range. So what would you guys say the domain of this one is? All real numbers, very good. And what about the range? So yes, those are the correct numbers. We just start with the smaller of the two. So negative infinity to -1. Okay? Or we could also write that as y is less than or equal to -1, right? Okay. All right, last one. Okay. So normally we have a vertical asymptote at 0 for this one, right? We normally have something like this on the x-axis, on the y-axis, something like this on the x-axis. So it normally looks like this, right? Okay. But here we have something with the x, right? So it tells us to pick up our whole function and move it to the right 3. So instead of having an asymptote at 0, I'm going to have an asymptote at 3, right? And did it say to move it up or down any? So then this asymptote stays at the same spot, stays on the axis. So this piece is still here, and this piece is still here. All right. So what would we say that the domain of this one is? Where does it start at? If it's going this way. If I'm going this way, where am I headed? Right, so from negative infinity, and it continues all the way until here, when it gets really close to that vertical asymptote, which is at 3. And then it stops, but it's going to pick back up again, right? So it's going to go from 3 off to infinity. All right. All right, what about for the range? How would I write the range? Same thing, but I trade out the 3's for, All right, because my range is my up and down. So this time we're looking at the horizontal asymptote there. Very good.